All right, everybody, good afternoon, and welcome to the Johnson Space Center here in Houston, Texas. I'm NASA's Gary Jordan. Thank you for joining us here today. We have a very exciting announcement today to reveal the companies who have been selected to move forward in developing the next generation of spacesuits that will be used for Artemis missions to the moon, as well as at the International Space Station in low Earth orbit. We have some panelists here today that will be providing remarks and answering questions regarding the new award. Here at the table today, from left to right, we have Vanessa Weich, the director of the Johnson Space Center, Lindsay Aitchison, program executive for the Extravehicular Activity and Human Surface Mobility Program, or EHP for short. She's coming in from NASA's headquarters in Washington, D.C. We also have Dina Cantella, Operations Integration Manager of the International Space Station Program here at the Johnson Space Center, and Laura Kearney, Manager of EHP here at the Johnson Space Center. We, of course, also have representatives of the awarded companies to provide opening remarks and address some questions, but I won't be the one spoiling the fun. I'll leave that to Vanessa Weich. We'll first start with some initial remarks from each of the briefers before opening it up for questions. We'll be taking questions on our phone bridge as well as here at the Johnson Space Center and, of course, on social media platforms. If you're on our phone bridge, press *1 to enter into the queue. And, of course, if you're media, you'll be raising your hand. And for social, just use the hashtag #AskNASA. So let's begin with some opening remarks with Vanessa Weich. Vanessa.
Thank you, Gary. I'm super excited about today. I'm going to do my best to contain my excitement. At NASA's Johnson Space Center, we have been working to have new exploration suit capabilities for a number of years. And we will have these suits, and they'll be made available for us to support the International Space Station as well as for our Artemis missions going forward. This is a historic day for us. And the history will be made with these suits when we get to the moon. We will have our first person of color and our first woman that will be wearers and users of these suits in space. So this is a very important day. We've had our internal team working for several years on a government reference design as well as technology that we made available to the companies that submitted proposals for providing this service capability. So without further ado, I am very happy to announce that the awardees will be Axiom Space and Collins Aerospace Industry Team. So congratulations, they're represented today, Axiom Space by Michael Seferdini, and the Collins Aerospace Industry Team by Dan Burbank. Congratulations. So this particular type of contract is going to be a task award. And so as they're developing the service, NASA will be certifying alongside to make sure that they are ready for our astronauts to be a part of them. And then once the suits are then ready, they will be used. These capabilities are for, as I said, for the International Space Station, and we anticipate that we will continue operations on the International Space Station until 2030. So it's important that we have a capability there. And for Artemis, the first use will be on Artemis 3, which will be the first lunar landing for over 50 years. So it's very important that we have these suits. I do want to also acknowledge the procurement and the legal team for all of the hard work that went into making this possible. It was over a year's worth of work to be able to get the proposal packages ready to go out with all of the requirements. Our engineering teams have put together the standards, and those requirements and standards that are needed were developed, and then these proposals, the companies have agreed that they're going to meet those requirements and standards, and so we will be able to have these capabilities tested, and they'll be tested before our astronauts are being used on orbit or either on the surface of the moon. So I just want to share that, this is a credible time in human space. I think most people are aware that NASA's Johnson Space Center continues to be a very critical hub for space exploration. We have missions today going on at the International Space Station. We're looking forward to our time when we'll go to the moon and then on to Mars. Thank you.
All right, thank you, Vanessa. Let's go to Lindsay Aitchison.
So as you might have gleaned from Vanessa's remarks, spacesuits have been a critical part of every part of our human spaceflight programs, going all the way back to the original missions back with Mercury, Gemini, and Apollo. And they continue to be at the forefront. You'll notice that spacesuits are going to be a key focal point when we take those first steps back on the lunar South Pole. And when we're there, this XEVAS contract is a critical milestone to getting us to that point. So we're all super excited to be able to reach that today. Recently, Congress agreed to formulate a new program here at the Johnson Space Center, and that program is the Exploration EVA Human Surface Mobility Program, EHP. And as part of that program that's managed by Laura Kearney, from whom you'll hear soon, we're going to not only develop the spacesuits, but also the human rover systems, which will help us explore more of the moon than we ever have before. The XEVAS contract is the first major acquisition of this new program. And under that, you'll see the commitment that NASA has to developing public-private partnerships across the agencies so that we can do more. Under this new arrangement, we're not only meeting NASA's objectives, but also helping to support and encourage an emerging space economy so that in the future, it's not just NASA EVA services, but there'll be a range of customers that can purchase that in the future. It's exciting, it leads to innovation, and makes sure that we have sustained competition along the way. And now to talk more about how the XEVAS contract is important to the space station program, I'll turn it over to Dina.
All right, thank you. All right, well, the space station program is really excited to be here today to be part of this announcement. You know, the existing spacesuit has been the workhorse for the agency for 40 years and has helped maintain and utilize the International Space Station as well as construct it. And so of the 250 spacewalks that are partners and we have done on board Space Station, 169 of those have been with the existing spacesuit. And so the spacesuit technology, though, of course, at 40 years is now aging. And so we'd like to try new future technologies. And we'd like to do it in an affordable way. And so this contract is actually a great part of our strategy for ISS for maintaining and utilizing the space station for years to come. And so as the providers will be certifying and demonstrating their technologies for new spacesuits, we'll be conducting an orderly transition away from our existing spacesuit and over to the new spacesuits. And so, you know, ISS, it's a test bed, and it's especially a test bed for exploration. And so we're looking forward to learning what we can on ISS and then handing what we've learned over to Artemis. And so we're looking forward to working with the providers as partners and bringing ISS and their spacesuits into the modern age, I'd say, and helping the agency on its way to the moon. And so next up is Laura Kearney, who's going to talk about her management of this contract as part of the Johnson Space Center's overall strategy. Laura?
Thanks, Dina. Yeah, good afternoon. So I just wanted to start by saying thank you. Thank you to the NASA team and to our industry team for getting us here today. Vanessa mentioned it, but it takes a lot of hard work and effort to pull a contract like this together. I know a lot of blood, sweat, and tears and late nights go into it. So I want to just put out my personal appreciation to everyone who was a part of getting us here today. As Lindsay mentioned, the EHP program, it's one of our goals really is to look for new, innovative ways of being more affordable, all while we continue to focus on safety and mission success. And I think this contract and our new partners, we're going to be the first ones out the gate in this program working towards that goal. We were really impressed with the proposals that came in, the ingenuity and the innovation that we saw in the proposals. We are very, very confident that together, collaborating with our partners and our NASA team, we're going to be successful. And we're very, very excited about seeing these new suits operating on the space station and on the moon. So I wanted to just extend on behalf of my team and my colleagues in the EHP welcome to our new team. We are super excited to be working with you guys. Put your running shoes on because it's going to be a very busy next few years, and we're ready to jump in on this great adventure with you guys. So congratulations and welcome to the team.
All right, thank you, Laura. We'll now go to the companies in alphabetical order, starting with Axiom Space. We have Mike Suffredine. Mike.
So first, I have to say thank you to my NASA friends and colleagues. Well, first, you thank them for the selection, but really, as Laura said, it's a tremendous amount of work to do the process of selecting contractors, and there's a tremendous amount of work on our side to create proposals, thousands of pages long, that these poor guys have to pore through every word and make sure it makes sense. And so my hat's off to the NASA team and also to the Axiom team and Colin's team as well for the work that's necessary to get to the point we are today. But what I think is really important about today is we have talked about, I've been on both sides, and we've talked about for many years public and private partnerships. And I think this is really one of the first cases where it's actually benefits both sides. Normally, as the agency is trying to pull commercial to start doing things, it's been about helping commercial develop so that they can provide a product that the agency can buy, and ultimately they'll be able to sell at some point. But in this case, we are building a space station. We have a need, Axiom Space has a need for a spacesuit. We have a number of customers that already would like to do a spacewalk, and we had planned to build a suit as part of our program. And so it's fantastic to have a partnership where we can benefit from the years of experience that NASA has and all the work they've done to advance a design to where it is today, and then us as a commercial company come in and work with them to build it in a way that's lowest cost, so that we can both utilize the suit to meet our needs. So we're very excited to be a part of this partnership. It is very beneficial to us both. One of the things that's important for us that we tell people around here, Axiom is a Houston-based company. Everything we do is done in Houston, Texas. Our spacecraft will be built here in Houston, Texas. The spacesuits will be built here in Houston, Texas. This job alone increases our size of our company by a little over 300 people. So it's a significant positive impact to the city of Houston and to our surrounding area as well. So we're excited to be here and appreciate the faith you guys have in us. So thank you very much.
Okay, and lastly, we have Dan Burbank with Collins Aerospace. Dan.
Yeah, thanks very much, Gary. And again, I'd echo what Mike said and thank the team that did the evaluations. I would thank the entirety of the NASA engineering team that laid this tremendous foundation with the work done on the XEMU. We've been partnering together for a long, long time. We, in the Collins team, we include also ILC, Dover, and we also have Oceaneering, 3 strategic partners, all of which have astronaut representation. So we try our very best to have the end user deeply embedded in the design aspect, because we want the spacesuit, although we'll often call the spacesuit the world's smallest spacecraft. It's human-shaped, human-sized. It shouldn't feel like a spacecraft. We want to be able to create an immersive environment that for the crew member gives them the most amount of mobility, that complements the crew member's capability rather than constrains it. So we're very excited to do this. We, our heritage corporations worked on the Apollo suit and designed and developed and fielded and operated that Apollo suit. So we've got some surface experience. We've also got more than 4 decades with a spacesuit designed for the space shuttle that was then evolved in its current iteration to be supported for 6 years on board space station with only crew members working on it. And in the process of doing that, we've learned an awful lot. So the goal is to take the foundations that NASA laid with the XEMU in partnership with industry and evolve that technology and create a suit that is compatible with the entire spectrum of crew members. So that commander of Artemis 3, she may weigh 120 pounds on Earth. And so that she has got a suit that's appropriately sized and tailored for her, that doesn't feel like a spacecraft, but feels like a ruggedized set of extreme sport outerwear. That should be the goal. And so we're very excited, very proud to be a part of this. We've been working for an awful long time with you, with your leadership, and very excited about the opportunity to go back to the moon and create a spacesuit that will also work for the follow-on years for the International Space Station and commercial LEO destinations as well. Very exciting. Thank you.
Very good. Thank you to all of our briefers for those initial remarks. We're now going to open it up for questions. We have questions on the phone line as well as folks here in the room, and then we'll be taking Ask NASA questions as well. For those on the phone, press *1 to enter into our queue to ask a question, and just make sure you state to whom you'd like to direct your question. If you find a question has already been asked, though, you can press *2 to withdraw it at any time. For those in the room, just state your name, affiliation, and to whom you'd like to direct a question. And then for social media, just use the hashtag #AskNASA. Let's go ahead and start here in the room. Mark Carreau, if you want to kick us off.
Thank you, Mark Carreau with Aviation Week. Is there a sort of target date for having a prototype that would be ready to assess on the space station? And would that be the kind of key milestone in this, or would there be something on the ground that might be as significant?
Sure, I can start. So we did require that the industry demonstrate in what we call a relevant environment. So we are leaving it up to them as to what that is. Very well could be on the space station, could also be in some kind of combination of say, lunar simulating environments here on the ground. So that is a major milestone to demonstrate that capability before we execute what we're calling services under this contract. As far as when, I would probably leave it up to you guys as to answer a when question. That demonstration ought to take place, but in the very near future, in the next year or two, I would say.
So I'd offer up one thing, Mark. So the development for our suit right now has been continually ongoing for a long time. So it's a rapid spiral development where we continually do a design, build, test, repeat, and evolve the technology as we go. It'll be tested in more and more flight-like environments, including thermal vac. I was in the suit this morning. In fact, I was almost a little late for today's event. So the suit is constantly evolving, and the technology is maturing, and the goal would be to be able to meet NASA's requirements on that schedule, whether that's 2025, which I believe we've talked about for space station demonstration. But I think we're well on track to do that.
And Dan said it right, Mark. It's more than just the demonstration, although the demonstration is a key milestone for us and others, because after that successful demonstration, we should be off to be able to do operations. But there's PDR and CDR and all the normal milestones we go through. We do those together with NASA, and it is our intention to demonstrate it in 25 timeframe as well.
Okay, excellent. Let's stay here in the room. If you state your name, affiliation, and to whom you'd like to direct the question.
ABC News. I don't know who wants to take this one, but in the past we've had, relied on the existing spacesuit as a mix and match, and there have been some issues with when the astronauts get in orbit, the fit wasn't quite right. How will this generation spacesuit solve that problem?
I'll ask Laura to respond to that, but we've been working internally doing what we call advanced technology development to look just at that, to make sure that we have sizing available that will fit, the 5th to the 95th percentile. All of those requirements we've actually put into the contracts that we'll have with both companies. But I'll let Laura speak more about that.
I think Vanessa said it really. We tried really hard in this acquisition not to specify the how, but the what. And so we did not dictate to industry how it should be done. We did levy the requirement that we fit a 5th percentile female to a 95th percentile male. We verified through the proposals that we saw, we believe their designs will do that. And so the process now is an engineering design process, and as they're going through that process, we will be there alongside them verifying that they are meeting that requirement.
And the goal is to do it with as few extra parts as possible. So we don't want to have 20 suits on orbit. We want to have a handful of suits and have them be very modifiable, if you will, to allow them to fit that range that NASA dictated and that we also support as well.
Mm-hmm. And for us today, that was exactly part of the test points for today were to prove that we could fit the taller crew members and the smaller crew members. In fact, it was exactly the same suit. And we did a rapid resize. It took about 30 minutes between evolutions, and we went from somebody that was considerably shorter than I am, shorter wingspan as well, and it worked really well. But that's not to say there's not always going to be opportunity to make it better and better. In Apollo, the suits were all custom made, so they were custom made for the crew members. And on Space Station and on Shuttle, we have essentially a modular-based spacesuit. So we don't have a fleet of spacesuits with 2 spacesuits per crew member. And to get the cost where you need to be, the challenge is to have a modular approach that does allow that full indexability and full tailorability. And I think we have line of sight on it. It's actually very promising. So.
Okay, let's go to the phone next. Again, if you're on our phone bridge, it's *1 to enter into our queue. Let's start with Elizabeth Howell from space.com.
Hi, and congratulations to the two companies. So I'm just trying to understand about how the spacesuits would work in the sense that you're going to be trying to design for micro-G at the ISS and potentially in other environments like that, and also for the Moon and Artemis missions. So are we talking two different types of spacesuits at least, or is this going to be more of a modular approach? And I'm thinking the two companies might want to answer, or perhaps NASA, maybe Joel, but let me know.
I'll start again. So, from all of the work that Vanessa and Lizzie both talked about that the NASA team has done, the requirement set for a low Earth orbit suit on space station and a suit on the lunar surface is not significantly different, particularly for the life support system. The differences really come in the pressure garment, the difference in being in zero gravity on space station versus having to walk on the moon where you need all of the mobility. So really at its core, the requirement set is generally the same. But in the previous question, we did not dictate to them that it be one suit, two suits, or whatever. We basically bounded for them the say up mass or stowage volume constraints that they would have either in a lander or on space station, and said you only have this much room or this much mass to fit extra parts. How then would you do that? And that's the way we were able to get the innovation from the companies, because they can tell us what they believe their best solution set would be to meet those two differing environments.
So one thing that's very different between the suits, well, I guess I would say, first off, mass is a much bigger constraint and a driver for a surface suit than it is in microgravity. So in microgravity, as a crew member doing a spacewalk, you could be in a 350-pound suit and it's not an impediment. In fact, maybe by some estimations, it could actually enhance, be a more stable platform to be in. But on a planetary environment, especially when you consider that environment is not an engineered spacecraft designed for a spacesuit designed for that spacecraft. Instead, you've got trip hazards and all in a surface that is not amenable to ease of motion anyway. So we would want to have a lower torso assembly that would have enough mobility for the crew member to walk naturally like they would on planet Earth. On a space station, it's actually not an especially helpful thing. Your legs, you don't really use at all. You use your arms to do the EVA activities. So you almost, on occasion, would you rather just put your feet into a foot restraint and have your lower torso be essentially like a pedestal, rigid, giving you good stability to work. Very, very different design, but it's really, that constraint's really driven by the lower torso assembly. So I think, like Laura said, the technologies, part and parcel with the life support systems, are very, very similar.
And that's the goal, is to make sure the suits are as similar as they can be. The other one that hasn't been mentioned is dust. Dust is a big deal on the moon, and it's one of the things you don't have to worry about in microgravity environment, but it's a big problem on the surface, so that's another thing that we have to deal with.
Okay, let's go to Andrea Leinfelder with Houston Chronicle.
Hi, thank you guys for taking the question. This one's for both Axiom Space and Collins Aerospace. Will you build the suits at the Houston Spaceport where you guys are building headquarter campuses? And Dan, did Collins previously build suits in Houston, or is this moving from another part of the country? Thank you.
So we will begin suit work at facilities here in the area. We don't move into the big spaceport for another year and a half to get into the high bay. So we got a lot of work to do before then. So we have actually a facility here that a lot of the work will be done to start with. Once we build up the campus at Ellington, we'll eventually move it over there.
And to tackle the last part of the question, back in for the Apollo A7LB suits and for the space shuttle suit, which became the space station suit, those were designed and built out of Windsor Locks in Connecticut at our facility up there. Here in Houston, there's a new facility going in at the spaceport that we're building, 125,000 square foot. A lot of the technology, the development, production of all of the components of the portable life support system will continue to be made in Windsor Locks, in addition to some other sites that we've got, both at our partner companies as part of the Collins team, but as well as some of the other Collins sites elsewhere. The assembly, the maintenance, the testing, and the sustaining of those suits will be done, largely here in Houston.
Okay. Okay, excellent. Let's go to David Curley with Discovery Channel.
Thank you, Gary. For the NASA folks, did you consider one company for orbital EVAs and another for the moon? Could you still do that in the contract? And can you talk a little bit about the fact that this is a services contract? The companies will own the suits. And for the companies, you talked about evolution. You're both pretty far down the road on suit development. What would those evolutions be?
Okay, I heard about 3 questions in there, so I'm trying to decide kind of where to start. So maybe I'll start with the first. So again, big day today with Axiom and Collins being awarded this contract. We have a step ahead of us. The way the contract is structured, we will now put out task orders for the demonstration periods, and they get the opportunity to compete on those task orders. And as we go through that process for a task order for the demonstration on space station capability, demonstration for the lunar capability, we will actually reevaluate those task order proposals and determine the best approach for both space station and for the moon. I know there was another question in there basically about services.
About the services. So, as was mentioned by both Mike and Dan, the public-private partnership is really a benefit to NASA, and it will allow us to have the capability to use, and then as well they will have it so that they could provide it for non-NASA customers. So it's a shared investment where we're both getting something out of it, but this will allow us to have services for both the moon and for ISS. And then the companies will also have the ability to have other users. And so that allows us to be able to save costs on the government side as we share this investment.
Let's see, and I'll answer your question about evolvability. 2 parts of that. The suits are not, we haven't completed critical design review, as it's called. There's a lot of work being done on suits and a lot of testing. As Dan's told you, a whole bunch of the stuff he's been involved in, that's in prototype type suits that ultimately inform the design. So there's still, at least in our case, there's still work to do to finalize some of the design, and you get informed by the work you're doing, testing in suits that exist today that you built up as you go. But from our perspective, you don't want to build a suit that never evolves. You want to build a suit that can evolve over time. So we'll build a suit, everybody will be happy with it, we'll start using it, we'll want to refine it as we learn more, we'll want to refine it to keep the cost down, we want to refine it to do the job better over the life of the suit. And I fully expect to see that over time as it will involve a design and evolve it even more once you get to the lunar surface as well.
Yeah, I would echo that. So I don't think there's anything improper or problematic about evolving the design. So in the development stage like this, I think that's just a natural thing you're going to do. I would say also with respect to having a suit that would work for one environment or the other, there's a tremendous amount of opportunity to have synergy, to be able to have a suit that supports the microgravity requirements. And then the things you learn there also help to inform the nature of how the suit would work on a planetary surface, like the surface of the moon. The suit's got to be interoperable with all the systems it interfaces with, so all the airlocks on International Space Station, on commercial space stations, on lunar landers, on pressurized rovers. The suit's got to be able to interface with all those systems as efficiently and as well as possible. A lot of those designs for the future systems aren't fully refined yet too, so I think there'll be an opportunity to make sure that evolution of the interoperability takes place. And the most important thing of all is the interoperability with the human element. So we think that is really critical, and we continually learn, and we're going to learn more as we get more and more crew members in the suit and learn how to make it better for them.
Okay, let's go to Joey Roulette with Reuters.
Hey, thanks. This one's for any of the NASA representatives. What is the value of each contract awarded today? And also, sorry if I missed something in the past with this, but with this new spacesuit program, what will be made of NASA's XEMU spacesuits that were in development? Thanks.
Way to go. So as far as the contract values, that information is going to be published in the source selection statement that is due to be out in the late June timeframe. And as far as the XEMU data, we actually have, through the end of this fiscal year, our team here in Houston, our civil servant team with our support contractor, continuing to work on that high fidelity engineering unit. They're putting it through a lot of testing. In fact, the life support system is in a chamber as we speak, running through tests. Pressure garment is also going through testing, and we, just like we have to date, we have a technical library that is available where we're making all of the results from the NASA tests available to these companies so they can use any and all of it as they choose. So we're continuing to run that GFE effort, the government effort, through the end of this fiscal year. And then the NASA team will shift focus and be in an insight oversight role and then collaboration team with our partners.
All right, let's go to Kristen Fisher with CNN.
Hello, everyone. Thanks for taking my question. This question is for anybody at NASA who wants it. First, I just want to confirm the target date for when you all hope to have these new spacesuits from Axiom Space and Collins Aerospace. I believe the companies said 2025, but can I just get a confirmation on that from somebody at NASA? And then, given the current issues with the spacesuits aboard the International Space Station, water and helmets and whatnot, is there any way that, or is there any discussion being had about, if either of these two companies could speed up the development of these spacesuits, if indeed the ones that are currently up there just aren't working anymore because they're so old? Thank you.
Okay, well, I guess I'll take that one. So again, we're going to transition the spacesuits on ISS and demonstrate them after they are proven safe and have worked through all the milestones that are necessary. And yes, we are targeting mid-2020s, and it will be aligned with the schedules that will be dictated by the providers. And as soon as possible prior to the Artemis missions and that particular need. So still clearly some, the schedule pieces are still being worked out and need to be worked with the providers. In terms of water and helmet investigation, I just want to first say that I mentioned that the EMU, the current spacesuit, is the workhorse for the agency, and as you mentioned, it's under investigation right now. And we have an extremely capable team, existing team, that's investigating what's happening at this point with the suit. In fact, we just received a status today. They have a lot of mitigation techniques they have already looked at for in case we have water introduction. They've been looking at the fault tree for the suit and have tried to identify where the failures could be. We're going to be down manifesting or bringing down on SpaceX 25, the spacesuit that actually had the most recent water and helmet anomaly, and so the teams will be taking a look at that particular suit. And so the team will be looking at all of that, and we'll do a formal review, at which point I'm confident that we're going to pass the same spacesuit, maybe with some additional mitigation techniques, absorption in the helmet or other types of mitigations, and we'll figure out what the cause was, and we'll be able to get through this particular issue. At which point that suit will be able and capable for many years to come as we work with our providers in that transition, an orderly transition. So just want to say that particular suit is still planned to be used until it is safe to transition over to a new suit.
All right, let's go back to the phone line. We have Jeff Faust with Space News.
Good afternoon. For the two companies, how much have you invested so far in suit development, and how much more do you plan to invest to complete development of the suits, either the dollar value or relative to the value of the NASA awards you've received? Thanks.
Let's see. That's a delicate question. Let me say this. I feel comfortable saying this. All of the cost to develop the suit is Axiom investment. So there you go. Now you got to go figure out what that is, but that's the Axiom investment primarily.
Yeah, and for the Collins team, I represent the technical team. more than the programmatic team. So I don't have a figure for you, but I would say that the work that's been going on for the last, intensively, specifically for a next generation spacesuit over the last year or so, that really is just the latest version of a continual investment in internal R&D and contributing technologies for the XEMU, for example, for the carbon dioxide scrubber, the fan, the pump, CO2 sensors, things like that. So a lot of that technology, it would be very difficult, I think, right now, at least in this setting, to be able to tease out how many things are actually work that we do that supports the existing EMU, work that supports the XEMU development, or this ongoing work we're doing on next generation spacesuits. We'd have to get back to you on that, I think.
All right, let's go to Daniel Reguera with Ardrone U. Sorry.
UI. Good afternoon and congratulations. The biggest question our people is asking in Spanish is how will it look, these new suits? If we can see any drawings or another pictures, or when we will see that. Thank you.
In terms of drawings and pictures, right now, today, the NASA team, because we're just now going into the award process, we don't have pictures to show. And maybe when would you have them available?
Yeah, shortly. Same. Yeah. So we don't have them for you available today, but
All right, very good. Let's go back to the phone line with Michael Greshko with National Geographic.
Thank you all so much for doing this. Quick question for the NASA representatives here. Could you speak to kind of the milestones or what the turnaround will look like going from a space station demonstration to Artemis 3? And then for the companies, could you speak to specifically how you all are leveraging NASA's investment in the XEMU program? Thank you.
So as far as the turnaround, again, I mentioned a little bit earlier, we are requiring that demonstration in a relevant environment. As Vanessa mentioned, however, for Artemis, the demonstration is actually the Artemis 3 mission. So we're actually calling that flight the demonstration mission. So prior to that, the actual flight of the Artemis 3 mission, we will have required that these folks can show us and verify the requirements in a relative environment, either on the ground or on space stations. So the timing for how that turns around, I think we'll just have to play out over time and see, how they hit their milestones and how quickly we're ready and heading into the Artemis 3 mission.
Yeah, and the other part, well, I think, and I kind of alluded to this a couple times already, so I think it really bears emphasis that the work that was done on the XEMU by NASA in partnership with industry, and we're very happy to have been a part of that, is a tremendous foundation. That work basically is a technological test bed for exploration spacesuit technologies, which all of our solutions are based on. So it is a very robust foundation within which we now have the opportunity to innovate, to drive down the mass, to drive up the mobility and the compatibility with the human element, to reduce the volume as much as possible. There's some things about the International Space Station and maintaining that, where there's some critical contingency kinds of activities where, as big as the space station is, there's some very tight quarters in certain areas. So to have a suit that's compatible with that kind of environment, I think, is really important. But foundationally, the approach is part and parcel with the path that the XEMU laid for us. And it's great to know that test bed is available going forward as well. And it's great to know the resources that have worked on it are available to partner with us. So we're very excited about that.
So what I'd add to that, a couple of things. One is we have some requirements ourselves, of course, that has to be accommodated by the suit that we have to design in. The other thing is, this has been fantastic work done by NASA, and of course we utilize it to the maximum extent possible, as Dan said. But each company has to own the design and own the integrated performance and own the integrated safety of it. So with this concept that has been evolved to the point that it is a very capable suit, we like it a lot. We have to now go back and certify it under our own conditions and make sure the integrated suit, once we put all the pieces together, actually perform as one piece. So Dan said it exactly right. This is a great foundation. It informed a lot of decisions about how you enter the suit, mobility. Some of the system designs are really amazing compared to the suit. Not that the suit that exists today is not a great suit, but evolution's important. And so all of that's very critically important. So some of those are components we can go buy. Some of those are components we have to build. Some of those we'll look at that and say, hey, we'll do this a little bit differently because it saves mass, saves some other cost, or it's just a better way to do it. And then you have to do the engineering to integrate that all together as one certified design. So that's the job ahead of us. But the EVA suit is pretty awesome.
All right, let's go back to the phone. We have Zach Aubert with the Launchpad News.
Yes, thank you so much. Congratulations to both Acton and Collins. For the NASA representatives, with two companies being selected, this is similar to what we saw with the commercial crew vehicles. Is this for redundancy, or could we see NASA actually using two different suits at the same time, or is it one universal kind of option you're looking for? And for the company representatives, how far along into development were you when NASA started this kind of contract process, or did you start after it was announced? Thank you.
Yes, I think it's fair to say that, especially as we start, there's a benefit to having two companies. I do think it provides us some redundancy as we go forward. Again, we talked about the task orders that we have yet to compete, and we'll see how those flesh out. But again, it keeps competition in our system, which was also a goal. So I think between the competition to help drive costs down and also the redundancy, those were a couple of the major goals.
And I would also say, and Laura mentioned it earlier, that these were really good proposals. We're very pleased that we have an industry that is capable and able to make these kinds of submittals. So we're very pleased by that.
I think the last question was how long have we been in development prior to this contract announcement, the final RFP in its current version. So I would say that spacesuit evolution work had been ongoing for quite a few years before that, and it focused in on a more specific way after the ex-EVAS proposal itself, but the need for a spacesuit and the need for a low mass, low volume, modular, open system architecture, enabled suit, that had been something we've been working on for quite a while before.
For our part, our team is, as we talked about before, we've been utilizing the ex-EVA suit for a while. That development's going on, and many of our team members have been involved in that along the way as well. So it really starts fairly a few years back. That's informed the design that we propose and ultimately are in the middle of building now.
All right, next we have Micah Mainberg with Wall Street Journal.
Hey, everybody. Just want to make sure I got this right about the contract structure. Maybe this is for Laura. Is it possible, just given the way the task orders work, that one company could win all of them? That's one. And then, Dan, I just wanted to ask you real quick. Mike has talked about other customers outside of NASA. Does Collins have any plans for customer development for these suits, beyond the agency? Thanks.
Yeah, so contract structure-wise, you are correct. Theoretically, one company could win all of them. So we will put the task orders out. We will compete them. We'll evaluate them. We have to also understand what our funding availability looks like. That's actually the great thing about this contract, and the team that put it together is that it is incredibly flexible. So it allows us decision-making going ahead as we, see how the teams are doing, how are they meeting their milestones, are they not meeting their milestones, what kind of funding availability we have. We can actually make decisions to put NASA, in the best posture for supporting both Space Station and Artemis. So it's difficult to say today exactly how this contract is going to execute, but that was on purpose and by design, because we want the flexibility to be able to make those decisions as we see how these companies perform.
And the question for Collins, we've already engaged with several other companies for interest and for inputs on the design. The intent would be for the spacesuit to enable more and more people to experience space, the actual environment of space. We think it's to sustain a space station like International Space Station or commercial space stations, certainly to do surface operations. I think anything short of a spacewalk wouldn't meet the need, both from a systematic standpoint and also for all the other customers that are out there that really, you would want humanity and a much greater number of people to be able to experience space. So the challenge then becomes to accommodate the various potential customers that you have beyond NASA, to accommodate the different environments and to accommodate the different kinds of vehicles and systems that the spacesuit has to interface with. Just the nature of systems engineering in this day and age, the nature of modularity that you can build into systems, the amount of capability you can have at the component level, and the availability and accessibility for the rest of the spacesuit systems means you don't have to have a single bespoke system that's only going to serve one particular use case. And so the ability to have a waist entry version of the suit, similar to the existing spacesuit, the ability to have a rear entry version of the suit, the ability to remove, to get easy access to components there, to be able to essentially enable block upgrades and adapt to different customer needs, I think is really important. So our goal is to make a suit that really can do with minor modifications, can accommodate lots and lots of other customers. So. Yeah.
All right, very good. Let's go to the room, and we'll go to Mark Crow.
Thank you, Mark Crow from Aviation Week again. I was reading through some of the solicitation materials, and I sort of had the understanding that when these task orders or contract agreements go forward, the companies selected will also stay with the suits in terms of doing maintenance and maybe even be part of the control teams that provide operational support. So if I understood correctly, and I'm just kind of checking here, this is more than tailoring a suit for the prom. It's more about how to wash it and iron it and wear it again and
train for it as well. Yeah. So that's my understanding as well, Mark. So the idea would be you're providing EVA capability to your customers, and you own the assets, you own the development, design, development, test, eval, crew training, on-orbit operations. That piece, our team, I feel like we're in a pretty good space in that area, because we do real-time operation support for all the spacewalks that we have on station. But it is another level of engagement by us as a service provider, for sure.
Yeah. So I might follow up on that. We wrote the contract such that these guys, like Dan mentioned, they own the suits, they provide the service, the EVA service, but they are part of the overall FOD control team here at NASA Johnson. So at the end of the day, the mission is still a FOD responsibility. Mission risk is still a NASA responsibility. These guys are operating it. We've envisioned them in a back room supporting, the front room mission control kind of thing. So, there's a lot of definitions of operate, what that means. I mean, clearly they will be there supporting the suits during a mission, but it's the NASA flight control team in mission control that is actually, making the risk-based, I'd say, authority decisions during an EVA.
Okay, we'll stay in the room here. Let's start with, go ahead, you can go first.
Gina Sinceri, ABC News. So your consumers for this are the astronauts going out on spacewalks. Are they sending you wish lists for what they would like in their next spacesuit? And what's on that wish list?
No, that's a great point. And we have a saying, if you want 3 opinions, ask 2 astronauts or some equivalent of that. So you have to be a little, so there's a process by which the astronaut office would develop a crew consensus report. So you'd have a robust testing campaign that would incorporate a number of test points, and you would get, lots of objective data. That might be video, that might be data from the suits and so forth, but then you would get a lot of information from the crew in the way of surveys, in the way of workload and those kinds of things. So far we have been, there's 3 of us that have been deeply involved in all the development to this point, and we're very excited by the award because that means now we have the ability to engage the rest of the end user community on a very rapid cadence, and I think that's a very important part of this too. But everybody doesn't get a vote, so that wouldn't be practical, but there is a way to, with the crew consensus process and that kind of a testing process, to come up with a good solution. And it's not really just the end users, it's also the flight control community as well, and the engineering community. So yeah, it's a great community.
I think the one thing to add is that a part of the contracts would be the availability of the proposers to access the NASA expertise. So whether it be astronauts or other engineers, we have a way to do that via collaboration agreements. And so we will make that available to both of them, as well as facilities that we have here that are unique as well. So the Natural Buoyancy Laboratory, NBL, will be made available to them as well.
All right, let me pulse the room real quick. Go ahead, Eric.
Hi, Eric Berger with Ars Technica. A couple questions for Lindsay or Laura, I think. I just want to make sure I understand the contracting mechanism. It sounds similar to CLIPS in that the providers are paid only when they provide services. I just hope you can clarify that. And the contract award was $3.5 billion, I think, through 2034 for all the potential task orders. And that's a few $100 million more than the first HLS award that NASA gave. And so I'm just wondering, like, in terms of cost, it seems like a lunar lander is a more complex system than a spacesuit, and I realize this is a longer period of time you're providing services for, but maybe you could just talk about the value of that, those task orders, and why it is so much more than the lunar lander. So 2 questions on the contracting mechanism and the cost. Thank you.
Yeah, so again, I might phone a friend for my source board friends here on the cost, but.
So a little different than the CLIPS contract. This is an IDIQ, a much bigger.
Can you start over, Mark, real quick? Thank you.
Thank you.
Yeah, you're good.
Okay. A little different than the CLIPS contract. The CLIPS contract is where the agency's taking high risk and not really necessarily investing in the development the same way. So this is definitely different. The $3.5 billion is a total contract ceiling over the life of the contract. That is not the awarded amount. We guaranteed them an amount to make sure we could get them going and they had skin in the game. And we're going to be careful to protect that. These are commercial companies working on commercial systems for other users, so NASA can be one customer of many. So there's a little bit different, not apples to oranges there with HLS and XEVAS. So the $3.5 billion is a ceiling, and this is we've got a development piece and then a reoccurring services piece that are components of this overall contract.
Yeah, and I think, Mark, the HLS was just for that one demo piece as well.
The HLS contract is focused on development right now.
Yeah.
Okay, very good. Let's see if we can squeeze in one more from the phone bridge. Let's do Lauren Grush with The Verge.
Hi, thank you so much. I was just wondering, given the report from NASA's Inspector General last year on the problems and delays with the XEMU, how confident are you that transitioning to this commercial approach at this stage, which is 3 years to go, will guarantee the spacesuits will be ready by the 2025 landing deadline? I guess what I mean is, how does moving to a private approach make that or facilitate that that deadline? Thank you.
Yeah, so I think we've talked several times about all of the XEMU data that's being made available, and I think you've heard both Dan and Mike talk about how that's being utilized. So I really believe all of that data is helping to reduce the risk and speed that transition process up to the contractor community. I also feel like, though, like Mike said, getting it in their hands sooner, I think, is better because they take ownership of it sooner. And so they start to run on that path to hitting a deadline. So I think actually we were at a great place to transition just because of how mature the XEMU was at the time. And I think getting it to these guys sooner allows them to run.
All right, very good. Before we close today, I did want to toss to Vanessa Weich for some closing remarks.
Oh, thank you, Gary. So again, we just want to thank everyone for being here today. As I said at the beginning, we're all very super excited about this. You know, this capability is something, as we talked about from the previous suit, for 40 years, it's been the workhorse, and it is continuing, and it will move forward. Likewise, these capabilities we see are going to be what's going to take us and continue with ISS, will allow us to do Artemis and continue on to the Mars campaign in terms of the technology demonstrations that we will learn from this particular suit. I want to again thank all of our teams for all the hard work that they put in. And also this would not be possible without the support that we get from both our administration and our congressional members. We're very fortunate to get great bipartisan support, and we're very thankful for that. I just also want to say to both Team Axiom and to both Team Collins, congratulations, and we look forward to collaborating and partnering with you as we go forward and we return to the moon and we can continue on the International Space Station. Thank you.
All right, very good. Thank you, Vanessa, and thanks to all of our briefers for taking the time to answer a lot of the questions today. And of course, thanks to all who were able to participate in today's press conference. You can follow along with some of the progress on this award at nasa.gov/suitup. Thanks again for joining us. That will wrap up today's briefing.